Okay, in this example, it says the energy provided each hour by the heat to the turbine is 7.25 joules. If 4.1 times 10 to the 12th joules of energy is exhausted each hour from the heat, the engine is heat, what is the efficiency of the engine? So basically you have heat that is generated to turn a turbine. Okay, and this turbine is going to spin as the heat moves and rises and causes the turbine to spin. So what it says that the power plant uses 7.5 times 10 to the 12th joules of energy is coming in. Now it says that you actually exhaust 4.1 times 10 to the 12th joules is heat. So you actually lose this 4.1 times 10 to the 12th, which comes off and doesn't actually do anything. So now what you have to do is let's look at our given information. So we were given a total energy, I'm just going to call it E for now, and the total energy that was put into the system was 7.5 times 10 to the 12th. We have the energy that's actually used, I'll go ahead and just call it work, because that's what we get out of it, is 4.1, oh excuse me, not work, that's heat that's lost, is 4.1 times 10 to the 12th, also in joules. What we're trying to find is, what is the usable work? How much work do I actually get out of this system? So the principle that's involved here, once again, is the law of conservation of energy. So we're not really sure if we have any relevant information yet, but we do know that the formula that we have is the efficiency is equal to the work that I get out divided by the energy that I put in times 100. Now, unfortunately, I don't actually have the work that I get out of it, because I am trying to find the efficiency, not the work. So I don't actually have the work that I get out of it, but remember, you have a total amount of energy. That energy has to go somewhere because of the law of conservation of energy. So I told you how much we actually lose to heat, so we should actually know how much we get from work, because this energy is really the change in energy of the system. So what I can do by saying that is says if I had 7.5 to begin with, and I've got 4.1 that's lost as heat, you can actually just subtract those two, and what you'll get is the actual work output. So that would be 3.4 times 10 to the 12th joules. So now I know how much work that I get out. I can calculate the efficiency. 3.4 times 10 to the 12th divided by 7.5 times 10 to the 12th. And what you should realize is these both have times 10 to the 12th, so those 10 to the 12th cancel out. It's really just 3.4 divided by 7.5 times 100. When you do that, your answer ends up being about 45.3% efficient. Now that's a very, very highly efficient engine. Most cars that are on the roads today get somewhere between 10, 18, some of them can get up to about 20% efficiency as far as gasoline is concerned. So something that's 45% is very